Good afternoon, welcome back to the chemical bonding valency bond theory and hybridization. Yesterday we have seen the methane sp3 hybridization. Today please listen carefully, there are some interesting points and most of the time that will be repeated, and if you are not able to understand then that will be all the time lifelong a confusion. See, yesterday we have seen methane. Methane is sp3 hybridization, very simple, and bond angle is 109 degrees 5 degrees. This thing because carbon is 1s2 and 2s1, 2px1, 2py1, 2pz1 we have seen, and the total this 4 1s and 3p total 4 called 4 orbitals and 4 hybrid orbitals. 4 hybrid orbitals is forming the 4 sigma bonds with the methane. This is yesterday we have seen. Very nice, and nothing is the confusion, and very easy to understand. Now, interestingly, the problem will come here. Ammonia also, this is the tetrahedral and all, everything is okay. Interestingly, ammonia is also sp3 hybridization, where it is forming 3 molecules form. Here it is a 4. 4 is the tetrahedral and everything is okay, and bond angle is 109 degrees 5 minutes and all these things. Now here how it is will happen. There is an interesting story. Okay. Here also 1s2, remember, 2s2, 2px1, 2py1, 2pz1. See, but here 1 s orbital and 3 p orbital, here also 4 orbitals are hybridizing. Here all 1 electron fellows. Here s orbital, 2 lone pair fellow and 3 p orbitals. Hybridization is from between sp3. So result is the 4 orbitals are hybridizing and giving to the 4 sp3 hybrid orbitals, but not all the 4 are equal. Not all the 4 are equal. Why? Why is there is a 1 lone pair orbital is forming and 3 single orbitals are. So here again what will happen? 1 central atom nitrogen, and the if you see these 3 hydrogen atoms, it is forming the 3 sigma bond with the hydrogen, sigma bond with the hydrogen, sigma bond with the hydrogen, sigma bond with the hydrogen. Okay, but here there is a lone pair that is in the 2s2. Because of this fellow is some distortion is taking place, and bond angle is 107 degree. Not this is sp3. This is also a slightly this one what you call the tetrahedral geometry, but there is a bond angle is different. Okay, now coming to the H2O. H2O, it is also interestingly another interesting story. Here sp3, so 1s2, 2s2, 2p2 means 2p4, means 2p2x, 2py1, 2pz1. That means there are 2 lone pairs and 2 empty orbitals. 4 are mixing together and forming 4 hybrid orbitals of sp3, but all the 4 are not similar shape and this thing same, but 2 are having the lone pairs. So he in the same story, 1 lone pair, another lone pair, and 2 sigma bonds with the water. So it is looking like a benta, and the bond angle is 105 only. It is 104, actually 104.5. 104.5. So this is interestingly difficult. So methane is also sp3, ammonia is also sp3 with 1 lone pair, H2O is also 1 lone pair, bent structure, not a tetrahedral exactly, and sp3 hybridization only. Don't get confused, because it is only forming 2 hydrogen bonds. Here it is only the 3, it is 4 is perfect. Okay, because sp3 means 4 orbitals. Now other so most of the time organic compounds only the hybridization all taking place. What happens in this case of C2H6? It is nothing but ethane. In the ethane, this is also a sp3 hybridization. Very simple. There is no much ambiguity in this. Carbon similar to carbon here. So one this is a 2s1, 2px1, 2p1 like this. 4 orbitals is forming with one carbon, another carbon. With these two are mixing together. That is C. This is a sigma bond between C and C, and 3 orbitals are like this with the hydrogen H. This is also sigma, sigma H. Similarly, this hydrogen sigma. So one sigma. So very simple. This is not much. Whereas problem will come with the C2H4. This is sp2 hybridization. Here, interestingly, it is not forming the means C double bond C. It is forming. Other two are okay. I am not writing. So here, what is happening? Only one S and 2P are out of this also. One S and 2P are only participating in the hybridization. This is for specially for only the carbon. See, sometimes it will form with the 3, sometimes will form with the 2, sometimes it will see another one also there. So here it is forming with the 2p orbitals and one s orbital, making one sp2 hybridization, and one bond is the sigma bond, another bond is a pi bond with the hydrogen. This sigma bonds, hydrogen, that is hydrogen sigma bonds. This is a pi bond. This is sp2 hybridization. See, drawing it may not be clear, and here you can see this thing. This is the one sigma bond and one pi bond in the bottom. You last see in one C, pi bond and pi bond. This is the final structure, or this is the final structure. These two hydrogens are with the two sigma bonds, and one sigma bond with the C between C and C, one sigma bond, and C and C with another bond is called the 2p x-axis is a pi bond. So that is the interestingly here you have to remember, and this thing is carbon will form with the out of though available, there are chances of the with 1s and 2p. You case interestingly one more case you take C2H2. This is ethylene, this is acetylene. Here it is sp hybridization. Here what has happened? What is again problem? With 1s, only 2pz is only making a hybridization. That means 1s and 1p are only hybrid. There are permutation combinations. With 1s and 3p, with 1s and 2p, with 1s and 1p only is forming. Here it is a 2p, 1p orbitals is forming. So here is what is happening? C triple bond C and one hydrogen sigma bond and another hydrogen sigma bond hydrogen. But whereas here we only one sigma bond between C and C, other two are pi bonds. This is sp3 sp hybridization. Interestingly, so and if you see the structure will be looking like, so it is acetylene will be one sigma bond here, one hydrogen sigma bonds, and the pi bonds if you see 2px and 2px there is a pi, and 2py there is a pi, and okay with the z axis anyway this is there. So this is also one kind. So interestingly in the carbon there will be so many slight variations are there, whereas in inorganic like the ammonia and the H2O and all not that much, but of course they are also here because of lone pairs the bond angles and all different. So interestingly this will be there, and when it is coming to the organic chemistry and all, please remember this type of things many more, and don't get confused in the while answering the questions and all these things. So last one is with the sp3d and sp3d2 also. This is the another d orbitals hybridizations also. Then we will see. Then another one is the coordination bonds. So far we are seeing the covalent bonds. Covalent bonds is sharing of each one electron and the it will be for the both. Whereas coordination bonds, coordination means one fellow is only giving the electrons and these things. So that we will see tomorrow. Thank you. Please remember very carefully, if you have any doubts and all, you can put in the view and all these things.